There are over 24 million compounds that we know of now. And of those 24 million compounds, they're all formed in a similar way. It's all a chemical combination of two or more elements. There are a couple different laws that we need to know about when we're talking about compounds. Now, the whole concept of a compound was stated by Dalton, and he said that all atoms will combine to form compounds. Now, he didn't quite have a grasp of the understanding behind that because he said that all compounds would be identical and so forth and so on. But he did kind of introduce the idea of the compounds and provide us with the language by which we devise them. For example, we talked about before, when we have CO2, we have one carbon for every two oxygen atoms. Now, some things that he didn't take into mind, though, were the law of definite proportions. Now, the law of definite proportions states that no matter what your sample size might be, you always have the same ratio of one element to the next. So if we had 10 grams of water, or we had 100 grams of water, we would always still have the same ratio of hydrogen to oxygen. So regardless of how much we have, the percentages, the breakdown would always work out the same. We'll go into how we do this in class when we talk about percent by mass. Percent by mass is simply a breakdown of the percentages that make up the elements in our compound. Percent by mass is calculated by taking the mass of your element divided by the mass of the compound. Let's say we had a 50-gram sample of water. And in that 50-gram sample of water, you determined that 5.55 grams of that was hydrogen. To solve this problem, you would take 5.55, divide it by 50, the mass of the compound, and multiply it by 100. When doing so, you'd find that hydrogen makes up 11.1% of all water. You would then subtract that from 100 to find that hydrogen makes up 88.9%. This right here is a percent by mass calculation for water. Now, of those 24 million combinations of the 91 naturally occurring elements and some of the man-made ones, it's inevitable that some would overlap. One very popular example is something you're familiar with, water, and something that your mom probably used to clean out your cuts, hydrogen peroxide. Note that the same two elements make up your samples, hydrogen and oxygen, but they exist in a different amount to each other, relative to each other. And so the law of multiple proportions states that when different compounds are formed by a combination of the same elements, different masses of one element combine with the same relative mass of the other. In this case here, the same relative amount would be the hydrogen. There are two atoms of hydrogen in both cases here. If one were to compare these to each other, they would find that the opposite atom, the oxygen, exists in a 1:2 ratio, where there are two oxygens in hydrogen peroxide to every one in water. This one here is more of a definition-only based thing. It's not something you need to be able to calculate too well. But if you were to have to look at this, say for an extra credit type thing, what you'd want to look at is the mass ratio. And that would be given to you from the equation. But you always want to compare the mass ratio of one to the next, and then you compare those two compounds to each other. Not going to get into a whole lot of depth about this, but we may do a few calculations in class.